You made it. Yeah, that's amazing.
I hate Windows. Loading screen.
I would have bought that kind of shirt from you when I was in college.
Yeah, I know, right?
I mean, I'm coming to the tech. If you got
I like the hit on the front there too. Hey, Manny, what's up?
Sorry, I meant to be here. I did. I got you.
Yeah, this is going to be kind of an experiment because of the location and all of that. It's going to, yeah, I imagine a lot of people are going to show up late. So
there was some traffic on 215, so.
Yeah, I know. My directions told me to hit Russell down, so I just took Russell all the way from the 215. I don't know. Maybe I should make it a little bit later. All right.
I mean, I left it. I mean, I'm up in Summerlin. I left at like 5:40.
Yeah.
It was clear all the way because traffic's going the other way from that side of town. So I didn't hit anything. It's the long is running down Tropicana.
Yeah.
There's no close exit, so get off on 215 and then just take Tropicana for 8 miles or something. That's
Yeah.
half the time it's down Tropicana.
Yeah.
Is it the first one here?
Yeah.
Yeah, I guess people will get used to it.
Well, this is the second one. We had one here probably like, Cody, when was the workshop, the Kubernetes workshop we had here? Last year? Was that last year? Yeah. So we had one here before. Yeah.
We were up in the,
Yeah, they have like a workshop up here that has like desks and everything, but we didn't need, and plus it's a smaller space. So we had like over 40 RSVPs between the two user groups, but I suspect half will show up. So
Even still, this is small so far.
yeah.
Out of 40, you usually expect to get at least 20%.
Like I said, they'll trickle in.
Yeah.
I think a lot of people just don't anticipate the location and the drive. And
Yeah, I didn't know they had this space. This is a good sized space
yeah.
for presentation.
Yeah, so I tried to get Blackfire, but they wanted $150 a month. So this place,
For 1 hour a week? Or 1 hour a month?
for a 2-hour event, they would want $150. This place did it for $0.
Yeah.
So
I like free. Free is good.
yeah,
I miss the innovation.
No, we will sing their praises because of it.
exactly. Yeah, we'll do a shout out to them here in the beginning. All right, let's just wait a couple more minutes. I have some waters, a couple club sodas sitting in the bottom of that chest if you guys want any. If you guys want soda or a snack, there's like a vending machine all the way down over here. So. I like those farm doors. Yeah, those are sweet. My wife was like, we should get one in the house. Like, and I'm like, started looking at it. You can do them yourself, but I don't trust my engineering skills when it comes to that. I'm good at software, not hardware. Like that's what I always say.
So when I did the one at my house, the key is you just put up like a 1x4 across the studs, and you can screw it anywhere because they want you to space it out, like that's all evenly spaced. The studs aren't evenly spaced in your house. So what you can do, which I didn't do, is you can cut out the drywall and mount that right against the studs, and then it's flush. I just mounted it right to the drywall, so there's just a little 3/4 inch board at the top.
Okay.
So there's a little bit more of a gap, but it's for a bathroom door in the master, so who cares, right?
Yeah.
Doesn't matter.
Yeah. Plus, if you paint it or whatever, it probably blends right in.
I
Yeah.
mean, the crazy thing is, it's just not that expensive. I mean, the door came with the door and the hardware and everything. I think it was like $200.
Hey.
So it wasn't crazy at all.
Yeah. What's up?
How you doing?
How you doing, Devin? Nice to see you. Yeah. All right. Shall we? Here, let me steal your microphone real quick.
Got it, man. There you are.
You good, Ryan? All right. All right, so welcome to Vegas Programmers. Appreciate those of you coming out. I'm sure we'll have some more trickling in as the night goes on with our new location here at Corporate Co-working. So I appreciate Tony who owns a joint. He's super awesome. I asked various venues here in Vegas if they could sponsor our user group, and Corporate Co-working was the one that stepped up. So shout out to them and supporting the local community. And I won't name any names, but various organizations that are owned by certain educational company or establishments here in Vegas. I wish they would step up, but apparently not. They want me to go out of pocket. So thank you to this space. So everybody, round of applause for Corporate Co-working. Thank you. And those of you on the live, if you do want a co-working space, this is obviously why they sponsored us. So they have great places to work out of here. I've worked out of here a couple times. Cody, you worked out of here too, didn't you? Yeah. Nice and quiet, cool vibe, good people. Coffee always on hand. So in fact, there might be some back there. I might go digging a little bit. So we've got an awesome talk lined up. Amin is going to be speaking about Linux Server Deep Dive. Who here likes Linux? Who here hates Windows? So yeah, I'm excited for this talk. This should be an awesome refresher, not only for me, but those of us who probably know CD, CAT, and then that's about it or whatever, and we're looking for the cooler stuff, right? So, well, I know grep too, but, you know, not regex so much. So cool, we're gonna dive into that, and then we'll probably have like 15 minutes at the end. I wanna cover a little bit of what I've been doing with AI and programming. And then, you know, we can kind of like the old days, just at the end here, we'll have like an hour to catch up with each other and, you know, see how everybody's been. So I'm kind of glad, you know, we have this new space, new time in some sense, because it brings it back to the core of what the Programmer User Group was all about. People are here to learn and to get back to the community of what they've learned. And that's what it's all about, right? So I appreciate all of you guys who, some faces that couldn't make it on Saturdays who now can make it. That's awesome to see you guys here. And yeah, so I guess without further ado, we'll bring up Amin. We do have a JetBrains license to give away at the end here, as usual. Yeah, if anybody, I guess, has questions during the talk, can they raise their hand and kind of chime in? Yeah, cool. All right, sweet. Then let's get to it. Oh, thought I was holding that the wrong way the whole time. I was good. I was good. Okay. Good, yeah. Clip those both on you.
You got it, man. Thank you, Josh. All right. Stand by. All right, I'm properly cyberized. Let's get started. Hey, everybody. My name is Amin Astani. I am presenting Linux Server Deep Dives, and maybe a little extra content depending on how you're feeling. You let me know. So who am I? I am a DevOps and site reliability engineering expert. I run a consultancy called Sharedomoto, where I help tech companies and software engineering teams launch and scale their production systems. Prior to that, I worked at two companies. I worked at a company called Acquia for 9 years. I helped them scale from 300 to 40,000 Amazon EC2 instances and ran their DevOps and SRE program. And then I was at Meta for a few years, helping run the production engineering arm of a team that ran 15% of all of their production workloads. And that was mostly AI models. So that was a really interesting time when I was working there. Enough about me. What are we talking about? So we are going to talk about CLI tooling on Linux systems that allow you to understand what's happening on the host. And there's two reasons why, depending on what camp you're in. How many of you are like system administrators? Rock on. Welcome. I love you. So Linux runs everywhere. I think you understand that. Most of the internet runs Linux. So this is going to be really good material for you to know how to better support and do performance engineering work, because we're going a bit deeper than the classic stuff. And then for you software engineers in the room, this is a great way for you to have a more intimate understanding of what happens when your code is running on actual infrastructure, which is a really important thing. And the ops people would definitely agree with that sentiment. So just a warning, this is not your usual Linux talk. This talk is in two parts. Actually, now it's one part. We won't be discussing the classic CLI tools unless you want to, and we're going to talk about that next. This talk is about the really, really interesting stuff, namely Linux, perf events, and eBPF. That's what we're going to be talking about today. But pause. I also have a deck called Linux Troubleshooting Secrets Revealed, where we go all the way to the beginning, and we are talking about tools like top and VMstat. So if you're wanting to get a refresher from the basics on how to troubleshoot a system and those classic CLI tools, like raise your hand. We can take a quick detour, well, a 30-minute detour, and go over that content. If you want to go deep, we'll go deep. How many? We're ready to go deep?
Yeah.
Deep it is. All right, we're going to keep on trucking.
Hey, Ahmed,
Yes.
I'm just OCDing this one. It looks like it's just a little too high and it's like pushing up India. So.
Oh, like lower, lower,
No,
lower?
you're right.
All right,
Sorry.
thank you very much. Yeah, you're good? Okay, awesome. So some housekeeping. The tools that we're going to talk about will introduce a performance overhead. The one that you definitely are going to have an overhead on is a tool called strace, which I'll be mentioning in the beginning of the talk. So just keep that in mind. You need to consider whether or not you want to run these tools in production. If it's an emergency, do what you need to do, but it might be best to test in non-production when possible. And most of these tools, if not all of them, require root. So if you don't have root, it's going to be difficult for you to be able to follow along. So what's the environment? What are we running all of this stuff on? This is Ubuntu 22.04 VM. We're running Drupal. It's a LAMP-based CMS. So Linux, MySQL, Apache PHP. Basic resources on this VM. And I even capped the disk I/O to make it replicate like an older server or something that's running in the cloud. You're probably wondering why I'm not running the latest and greatest Ubuntu. The latest, greatest Ubuntu is broken. So when I tried to put up the demo environment, a bunch of stuff didn't work. So, and I found these bugs. So we're doing 22.04 right now, which is what I actually run on that laptop. All right, so let's get started. Let's begin with some operating systems basics. How many of you know about system calls? All right, we got a few of you. So this is going to be a review. That's good. So for those that don't know, system calls, or syscalls for short, is how applications interact with the kernel. The kernel is controlling all of the resources, and system calls are basically the API, the means for a process to request things like access to files or talking to the network or even executing other programs, things like that. And if you want the reference on the full list of them, you can run man2 syscalls. And if you want to read the reference on a specific one, you can run man2, the name of the syscall. And that will be pretty important throughout this talk, just in case you're curious about which one we're talking about. So to begin, we haven't even gotten deep yet. We're still on the surface. We're talking about stuff that's been around for a long time, but we need this for context. So let's talk about strace. Strace is a system call tracer. So basically, you take this tool and you attach it to a running program, or you can have it run a program for you, and it will tell you in real time what it's doing, what file accesses are happening, the network calls, all of that stuff. But the problem is with it, it significantly slows down execution. So, you know, strace is a lovely tool, but it does have a serious performance con. You can't run it all the time. So here is a basic example on the output of strace. This is the bottom of the strace output for cat devnull. So devnull is just the bit bucket. You write things to it, nothing comes out, and cat is print the contents of the file. So what happens is you can see there is the open system call, and it's opening the path devnull, and it's returning something. That is called the file descriptor. That's going to be important in a minute. So that is basically a reference to this file. And you can see it's even open in read-only mode, so we're only reading, we're not writing to this. So there's your system call, and that's a file descriptor. And again, there's a manual page for each system call, so you can look up what these things mean. Now, here's a more interesting example. I am stracing a PHP process running Drupal, because that is our example, and you can see some stuff here. So we got the send to system call. Well, I don't know maybe what that is, but that sounds like maybe I'm sending something over the network. I got a file descriptor called 11, and then I have select da 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 da. That's a select statement. So we know that this is a database statement to MySQL that's happening in real time over the wire, or rather over the pipe, but you get where I'm talking about. And then you can also see the response. So you're able to intercept database statements that are happening. You don't have, if you don't have access to source code, if you're not knowledgeable about what a tool or a process is, like how it's written, you can still figure out what a process is doing on a running system. So this is the output from strace-f, which is follow processes that are launched, the process ID, because every program that runs on a Linux system has an individual process ID. I'm sure it's the same on Windows. You reference that, and you're able to intercept calls here. And then also -s1024, which means the number of characters of output from each syscall. You can make it as big or as little as you want, but these are the parameters. And you can customize strace. You can say, hey, I only care about these calls. Maybe you just want to think about the network traffic. You could exclude calls. This is pretty common when you have like an APM installed, like New Relic. It'll do this all the time to figure out how long it takes for things to run. And then you can even do -t, which will tell you how long each syscall is taking, which is great if you're trying to find something that isn't performing super well. Everybody good so far? Rock on. All right, we're going to keep going. And please interrupt me if you have a question. So what do we do with this strace tool? Great. Well, several things. Like I mentioned, you can observe database statements that are happening. You can see HTTP stuff. You can see accesses to files, reads and writes. You can measure the time that's spent in each syscall, and particularly which syscall a process is stuck on. So if you're tracing something and then it just stops, and it just has like a particular call name and a file descriptor, you can figure out where the file descriptor goes to and say, oh, yeah, there's a performance problem, maybe reading or writing to a file or a database, which brings us to this. So strace is, yes, go ahead.
So if your process stops, can you run strace on it while it's hung, and will it give you the last syscall still, or you have to run it before it hangs?
From what I remember, it will print out the current syscall that's running,
Okay.
which is pretty cool. I used to use strace a lot when I was at Acquia doing support on production websites, and I would be like, oh yeah, this thing's trying to read write to a file and it's stuck, and the network file system is stuck. So yeah, you definitely can. That's an amazing question.
Another question. So in that case, were you like attaching to Nginx or like whatever web server, or like a PHP FPM?
A PHP FPM process. So for those that know about like Drupal or WordPress or any PHP-based application, I typically use this to attach to PHP processes. The same can be said for any application runtime. That's where strace really sings.
With FPM, there's like a ton of workers, so this sounds like it attached just to one process. So how do you know which one to attach it to? Do you attach it to like the master process?
So if you do -f on the main, it will then trace the children too. Oh, I mean, and you're asking a really good question. So what I used to do in the past is I would do a PS, forest, and that would give you all of the processes and the relationships between them. So now I would know, oh, okay, this process ID is for a PHP process that is running underneath the PHP FPM parent. I would trace that, and then I would know just that particular page load, what that's doing. So you can do the parent, but usually I try to find a child and trace that instead. That's a great question. So LSOF. strace gives you, well, file descriptor IDs, like we were mentioning earlier, right? That's a file descriptor. LSOF actually tells you what those file descriptors map to. Because sometimes when you're tracing it, you'll just have a reference to the file descriptor, but you don't know where further up the open happened. So now, here is LSOF on a process. Now, how many of you have watched the movie Hackers? All right, so check it out. Somebody has the garbage file opened over here, and you can see it's open on file descriptor 3, just like the movie, right? And we can take a look at what's going on here. So LSOF has all kinds of stuff. It tells you, what the current running directory of the process is. It tells you the binary that is loaded in. It's telling you all of the libraries that were loaded in, the shared object files in order for the program to link and then load. It's also showing you like the console that Vim is running under, and then finally the file, or rather the swap file that is open to do this. So this piece of output gives you a lot. So in the case of you running LSOF on a process that you're running strace on, you're going to have, a reference to maybe a remote server where a database lives, or a remote web service, or a local file. Good so far? I'm going to check in a lot. All right, cool, thank you. So now that's the basics. We know what system calls are. We know what file descriptors are, some basic operating system stuff. Time to go deeper. We ready to go deeper? All right, let's do the thing. So from here on in, I'm going to go move here because we're doing some demos today. Yes?
Were any cats harmed in the making of this presentation?
Sadly, no. No, though I love that GIF. That's so great. No cats are harmed. I'm a big fan of cats. All right, so.
I have a question too. I'm curious about the Acquia. What do they do that they have 40,000 servers running?
They provided hosting for Drupal websites. And the founder of the Drupal open source project, Dries Buytaert, is the founder of Acquia, the company. Okay. So if you think of like WordPress and Automatic, Drupal and Acquia, it's the same relationship. Cool. Yeah, so I was there for 9 years and did ops there and then the SRE thing. Good question. All right, so let's talk about some new tools, starting with perf events. It's been around for a while, since 2009, so over a decade. It's been part of Linux kernel, an ancient kernel. We don't even do 2.6 anymore. Originally called Performance Counters for Linux, and it allows you to analyze kernel events. Sadly, it's not really well documented. There's a wiki page that's been edited maybe a handful of times since then, but it's pretty easy to install. You just install Linux tools, and you might need to install the kernel headers with it too. We're also going to talk about the extended Berkeley packet filter, which, okay, yeah, it's a packet filter. It was originally written as a firewall, but it came with some really interesting stuff as part of it. Particularly, you're able to write programs in it. So eBPF's scope has expanded beyond just packet filtering. And there's a few things where the programs are loaded in the kernel. They can't crash and they can't run forever. And they access kernel internals. So that's why eBPF has really expanded in scope beyond its original purpose. So what this means is that we can use this tool for in-depth performance analysis of a running server and not just network. And there is a toolkit called BCC, BPF Compiler Collection, which we'll be going through a lot of today. And there's also the capability of writing your own tools. You can write your own tools in C, and you can write your own tools in Python, which really wrap around C. So sadly, if you want to do eBPF code, you're going to need to know a little bit of C. So that's how you're able to install it. I will say that, again, Ubuntu 24.04, it doesn't have all of the features that I wanted for it. And then on 22.04, I had to compile it and install it from source. That, yes, the packages are there, but that was how I got everything working, just to give you a heads up. So let's get into the fun part, which is the demos. So what's going on here? We got ourselves the Umami Food Magazine website. It's basically like the test website that comes with any Drupal installation. So this is what's going on under the hood. I also have a couple of login shells into the VM that's running the site, and we're going to start running some commands on here, and we're going to step through each of these in order. Let's start with the perf tool. So perf tool is what comes with the perf events package, and it allows you to do several things. It allows you to count the number of times that something specifically happens. It allows you to trace specific events, particularly syscalls, which is going to be really interesting. I'm going to do a demo shortly that's going to blow your mind. It allows you to capture specific events on the server via probing. And then finally, you're able to run reports on the output of whatever tools you run. So let's start with perf stat. So when we're talking about counters, if I run this command perf stat e syscall sysinter star, so basically this is saying, give me the count of all of the system calls that a given command does. You're then able to understand what the application that you've written is doing. So let's see if we can go and do that real fast. Right. So I am going to run drush status, which is the CLI tool that runs around Drupal. And it's going to go and check all the status of the app and hit like the database and do a health check. So if I run this, let's full screen it. Is that a good font size? Okay, great. Now check this out. So I now I can see that it is connecting to a socket on localhost 7 times. It's doing 45 send tos, probably database calls, 89 receive from. So you have a really interesting set of syscalls and their frequencies. And you can also see file activity, how many files this thing was looking at and opened and closed. So isn't it interesting? Like you can run a program with this and see basically what it did behind the scenes. Yes?
So can you pipe that to sort? I'm assuming you can't.
Oh, sure we could.
Oh, you can?
I mean, yeah, but of course, so I'm going to have to like, direct this output to dev null. I think this comes out in stderr, and then we're going to have to do some pipe sort. Yeah, we could do some of that funny business.
It doesn't really help you. It gives you the count, but it doesn't give you like the runtime.
Oh, of course not. Yeah. For this, we're like, so the perf tool, especially in this context, is pretty extensible. You can do a whole lot, and eBPF does even more. So this is a simple example of, process introspection. But yeah, you're absolutely right. So this just gives us like the number of times a particular syscall has been used. All right. So that's what that does. Now, remember we were talking about strace a little while ago? Well, the folks that wrote this wrote a replacement to strace called perftrace, and it is way faster than strace, so you can use it, a little bit less cautiously on your production systems. Now, I was trying to get this working on 2404, but the tool is missing. I think there's a bug or something in PCC tools, so I need to report that. But on 2204, it's totally available. So how do I know that perftrace is better than regular strace? Well, we did a test. Who knows what DD is? All right, rock on. So we're just making a big file here. You can see that. And so a 5 gigabyte file. And you can see when we just run DD on its own, it does 1.5 gigabytes a second. Now, if I run perfstat, basically just catching all the syscalls of that same command, okay, now the transfer speed is cut by 1/3. And then if I run strace, look how small that is in comparison to the original speed. So you can really see that strace really slows the process down, where perftrace, it does still slow the process down, but only by 1/3, at least in this test. All right. So the crazy thing about perftrace is that if you just run perftrace, it will print every single syscall that's happening on the system in real time. Right? So you are able to see everything that is happening on a system, which is just absolutely wild. Prior to this, you could only trace one process at a time. But with perftrace, you can see everything, which is kind of bonkers. It probably also slows the system down a lot, so I would avoid using that. What you can do, though, is you can do perftrace-p just like in regular strace. So you can just trace a single process at a time. But as I mentioned earlier, at a less cost penalty of performance. So we can also do something called perf record. where we are sampling all of the things that the CPU is doing on the system, and then we can generate a report on it. So we can do a quick demo here. Perf record. All right. So what we're doing is basically for 10 seconds, record everything that's happening at 1,000 hertz. So it's going to be sampling at that frequency. So we'll just wait a few seconds while that runs. It's going to output a file. And then we can do perf report. And then you can see what happened. So you can see that, well, the system's pretty idle. You can see that the sleep command that it was running took most of the time on the system. But you could see like the breakdown of all of the processes as well as the kernel threads in terms of the percentage of time that the CPU is running on the system. You can then drill into, you know, where in the application it's running. Now, granted, you can see a good chunk of the time is spent in this symbol that can't be dereferenced because I don't think the sleep command comes with compiled symbols. So for those that know a little bit about symbols, when you compile a package in debug mode, the binary gets really big because it has all the names of the functions. When you usually build an application, all that stuff gets stripped out. So if you install packages with symbols in them and you run this tool, then you can see like the call stack and how much time is spent. All right. So now perf top, similar. It's like top, but it's just for kernel. So we can run that real fast and see what happens. And I have a tool that crawls this website, right? So I'm just going to run crawl. Trust me, it's just a bash script that runs wget, and you can see that in that moment, PHP is doing a bunch of things, and we can actually take a look at that and zoom into it, and you can see that a good chunk of time is spent in the Zend hash find function, which is a feature of the PHP language, I'm assuming. So again, you can just run perf top and get samples in real time as to what's happening on the machine and drill in, which is really interesting. All right. And you can even run perf top and then just extract only network traffic, right? So you can filter it rather than doing all of the various calls to make it easier for you to understand and interpret what's going on. So here, perf probe, we're not going to do any demos on this because it's kind of esoteric, but I think it's really useful to know that this exists, where you're able to tell the Linux kernel, hey, for any event of this kind, just track it. And then you're able to then record behavior over time and then see the results. Again, we're not going to demo it because it's kind of esoteric, but know that this exists. All right. So BCC, as I mentioned earlier, comes with a bunch of tools already built for you. You don't have to write any of this stuff. And so we're going to spend the rest of the talk talking about this, which is going to be really fun and interesting, and you can try this stuff out at home. And I hope I ordered it by excitement. So we're starting easy, and then we're going to get into really crazy stuff. And feel free to ask questions. So to start, we have something called TCP Connect, and that allows you to see what your server is doing when talking outbound. So you could use it to detect intruders by seeing the TCP connections that are being generated by the system in real time. So let's mess with this. All right, so what if I talk to my website? You can see, oh yeah, look, source address, me, destination address, there, port. If I run the crawler command, it's going to do a whole bunch of stuff against myself. So running this, you're able to see the TCP connections that are happening on the system when they're being created, right?
So would that be valid for like SSH too? Like if people hop on?
Yeah, SSH, like any TCP protocol, right? So it could be HTTP, HTTPS, email, anything, so long as it's TCP, not UDP. Similarly, we can run TCP tracer, and you can detect all of the TCP connections. So if we run that, and then run our crawler again, you can see, again, more information about what processes and where over time on the system, as well as like the status of the connections themselves. So a bit more granular. You can also see if it's IPv4 or 6. So pretty interesting that you get this for free. TCP life gives you how long it takes for a TCP connection to exist, which can be really interesting to find out what your clients are doing. For example, maybe you put like an ISO, or maybe someone uploaded like a video that's copyrighted on your server. And if you run TCP live, you can see the connections of the long-running TCP connections that are like the long-lived downloads, and you can kind of see what's happening there. So you can find the speed, the transmit, the receive speed of the requests in kilobytes, as well as the milliseconds latency of each of the HTTP requests. So if a system or if a process doesn't have logs, you can still figure out how long a request takes, which is pretty cool, right? All right, let's do some interesting stuff. We're talking network, let's do some interesting stuff. So StatSnoop figures out what file information access. So stat is a system call that allows you to figure out like, oh, what is this file? Where does it live? Who owns it? How big is it? That sort of thing. So if we run this, do I have any? Might have to copy paste. All right, let's copy paste that. And then we need to sudo this. Okay, so what does this command do? It's basically filtering for anything that's happening in Drupal and anything that's referencing static assets like images and video, right? So if I run this crawler command, now you can see that there were requests to WebP files and JPEGs, and you can see that that there are requests for the wget command, as well as the client, as well as the server Apache 2. So with this, you can see in real time what files are being accessed by a process, which is really cool. All right, back to the slideshow.
Could you use that, like if the file is over so many, like the file so over this amount of megabytes or something like that, just to trace like large files, or?
I think that would require a little bit more logic, because you could in real time, I suppose you could modify an eBPF, like a BPF program where you are tracing all of the file accesses, and then you would conditionally say, hey, if the file size is this big, then print it. But yeah, I don't know if that tool has a capability, but the programming capability would allow you to do that kind of logic.
But if you're typing it to grep, can't you type it to
yes.
something else, a find command?
Oh, 100%. 100%. Though I will say, depending on the rate of file access, because remember this is stat. So for every single file that you're doing, you're now executing a command and response. So you have to think about the safety of doing such a thing. But I totally get what you're saying. Yes, you could do some shell scripting stuff, but the production impact could be measurable. Could be non-trivial. Good question. Now we have file top, which is just one liner. You don't even have to write any bash or pipes. And you can see what files are getting the most action. So if I run this, you can see all of the files that are being accessed and the read and writes to it. So this is really useful if you want to know, for example, like how much is the database? Like if I'm doing big file loads, you can actually see it on here, big I/O. If I run the crawler, we can see, hey, look, there are some, JPEGs and images that are being read and the rates and stuff. So for certain like processes that are only accessing certain files, like a specific set of files, you can see how much a particular file is being read and written to. So that's what that's useful for, and I think that's pretty grand. All right. We also have byte size. Now this is getting a little technical. So we were talking a little bit about network a little while ago. Now we're talking about file system. So you're able to figure out like the block size of read and write operations of a program. So if I run sudo byte size and run our crawler, because that's how we're generating load, you can see the distribution. So these are histograms of like the number of kilobytes, and you can see that, for this kernel worker, it's pretty distributed, but for this kernel worker, it's all large blocks. And I think this is a file system thread. So it makes sense that it's going to be writing as large blocks as possible to keep the count low. But now, yeah, you have a histogram of like how is a process accessing your data? Because if you're like, let's say you're reading and writing a byte at a time, that could be really slow. So that allows you to characterize how an app is reading and writing to data. All right. And then similarly, on the kernel side or on the file system side, you can run either any of these tools based on what file system you got, and it'll generate similar histograms. So instead of you just running IOStat, how many of you know about IOStat? All right, so this is a bit more in depth than IOStat. This will tell you on the file system level the histogram of how long it takes to do individual writes, and that might show you some interesting data about how long does it take to write certain block sizes and things like that. All right, let's get into some stuff that's a bit more interesting. So a little more operating system theory. A page fault is you're trying to access something from RAM. It's not there, so you have to go into the disk to get it and load it into RAM. So that's a page fault. And usually page faults, high rates of page faults, have a performance impact on your system. Ideally, you have enough memory on your machine where the file system cache has a whole lot of data already. So when you are doing those read accesses, you're not doing a page fault on a per file basis. So let's do some interesting stuff here with cache stat. And I can show you what's going on here. So every second, it's going to give me the number of hits and misses. And if I run this crawler, it's not going to have a whole lot of misses. Now, why do you think that is? Right, they're already cached, right? So let's say the server just booted up. We can do this. Who knows what I'm doing right now? That guy's a sysadmin. Let's drop caches. So now I just purged the file system cache. Now if I run that crawler again, look what happens, right? All that. So those are your misses. So so when we cleared the cache, the cache miss and the page faults increased temporarily, and then running the crawler populated the cache. Now if I run it again, you can see that the cache misses are still at 0. So now why does this matter? Let's say you're running this on a system where you're running a file server, and you see a lot of cache misses. it probably means you don't have enough RAM on your machine, because the Linux kernel holds on to, it uses your RAM that's not in use as a file system cache, right? And that's happening automatically. You don't tune it, it just works. So if you don't have enough memory on the system, every time you're trying to access files, maybe you're running like a home lab or something, it will just take longer to load because you're hitting the disk all the time.
But, installed, you can show them.
Oh, sure. I can install it now. Oh, looks like it is. Right, I see what you mean. So you have the amount of memory that is in use, and then you have the amount of memory that is in buffers, like the information that programs are holding in memory and passing between each other, and then the amount that's in cache. And you can see in this case, this is the amount of memory that's in cache. You can also do this, and you can see this is the amount of memory. This is the amount of memory in disk cache. This is how much is shared between processes, and this is how much is actually free. So he was referring to that. So go ahead.
Sorry, is there a rule of thumb for a healthy amount of RAM left? Like I still struggle with trying to figure out how many FPM processes I should spin up based on the amount of RAM I have available on the machine. I have my own calculation, but based off of like 3 different articles I read, everybody has their own way of doing it.
Yeah. It's been a long while since I worked at Acquia, but I can tell you that they wrote some code that took in a whole bunch of factors and then spat out like the maximum PHP process limit based on what you're describing. It's a pain in the butt because you have to like go into the PHP configuration settings. Hopefully it's just one site on there, so it's a homogeneous workload. You figure out how much memory is left. So capacity planning is it's non-trivial. What I will say is, I mean, take the amount of RAM that is free, after everything else. Like you have to run all of the SSH and all of the processes that manage the system. Whatever's free, yeah, you can probably divvy up between your PHP processes, but you probably want to have a buffer because there's cron jobs and some funny business or scripts that happen on cron that can consume an inordinate amount of memory, and you want enough buffer to be able to manage that.
It also depends what you're running on the server. If
Yeah.
you're running full LAMP stack, then the database is going to want
Yeah.
RAM as well as the PHP, where if you split it, you have an external database for making calls over the network, you have more RAM available for the PHP. So it depends greatly also on the type of traffic you're getting. You're getting a lot of static traffic because people are watching videos.
Yeah.
You want to cache those. You're getting a lot of dynamic CGI traffic. You're not going to need as much RAM for that.
That would be a good talk, capacity planning,
I love that.
right?
Yeah, capacity planning is huge.
And I'm sorry to deviate a little bit, but swap I also heard is a contentious thing. Some people say
Never
to turn
use
it
it.
off.
There's the contention. I'm also in camp no swap, but I'm in it for a specific reason because I don't want to wear out my NVMe on here, right? But if I'm running a production workload, there's been questions as to whether or not you want any swap at all. I've seen systems that only run maybe like a gig, but they're not, you don't want to be in a situation where you're using swap because the performance characteristics of the app severely degrades, like by order of magnitude, if you're being blocked on swapping.
Let's say you hop on and you're not using swap, but then during a high peak load it did. How would you even know? Is there like some log or anything?
It'll show you right there in free. It'll also show you in HTOP.
That and
But if it happened in the past,
right, so you're
It'll stay there.
so that used column
Yep.
right there is
Yeah,
what
we'll
you're
go up
saying?
and it will stay there.
Okay.
it will, but so talking about running a system at scale, it's okay. I think it's great we're having this conversation. I don't mind going in on a tangent for a little bit here. So there's the old school way of doing it, and then there's the modern way of doing it. The old school way is a term called process accounting. So there's tools like ATOP, which will actually store a file of what happened in the past. So it basically runs top over and over again and then stores it. And you then could figure out like, oh, at this moment in time, this was the amount of swap that was used. Now, if this was a production system, I'd probably have a time series database running somewhere like Prometheus. I would run the node exporter, and then I would have the host telemetry, which would be the CPU utilization, the memory utilization, the disk read-write operations, and that utilization, as well as the network. And then you can go back and query that stuff. So you bring up a very interesting point. These tools are very, very useful for point-in-time analysis. There's going to be moments where your monitoring system or your Datadogs and your Grafanas of the world don't capture the data you need. Sometimes you got to SSH in and look. And the tools that we're describing today are really good for that sort of thing. Once you learn what metric matters to you, then put it in your monitoring system and then put it in a dashboard that you can read back in time. That way, it's easier for you to answer those types of questions.
Just from a swap perspective, I still try and run a minimum of 8 gig, minimum, but you should match your RAM, because if you need it, it's there. The goal is it should always be at 0, just like it is here.
Yeah.
But if you don't have it and you need it, you have problems.
Right.
So disk is cheap, have it.
Gotcha.
Yeah, it's a good perspective. It might be better for you to be slow than to be down.
Yep.
Right? Because if you run out, you will invoke the killer, and then processes get killed off, and then you're down. But that's for a different talk entirely. All right, let's keep on rolling. So you have the cache stat tool. We talked about that. We also have the DC stat tool. That's a little bit esoteric. That's particularly for directory cache. So instead of storing information about files, you're storing information about directories. All right, let's continue. All right, we're turning up the volume a little bit. We're going to be getting into some pretty interesting stuff here. So PID per sec gives you the rate of new processes. So let's run that. And you're going to see it's 0 because I'm not doing anything. What if I do this? I get 1. If I do that, I get that. What if somebody wrote a terrible shell script? Right? So I'm cranking. I'm just making a whole bunch of processes on a per second basis. So when you're running PID per sec, if you see metrics like that, that probably means you got some kind of script or process that's going rogue, and it is just firing up a whole bunch of processes. Now, okay, great. I got a number here. What the heck is going on? So we can run exec snoop. That gives you that information. So we'll run sudo exec snoop. And now if I run that dirty shell script again, you can see, oh my gosh, it's firing up all these instances of uptime, and you can see the process ID. And I think this is the parent PID, so you can figure out who's calling it, which is probably what you care about. Yeah, see, this is the process ID of the shell, and that is the process that fired this up. So now you can figure out what parent is generating all this nonsense. So PID per sec. And this tool here, exec snoop, can be really useful, especially on like jump hosts where people are logging in, like Bastion hosts, things like that, things where humans are SSHing in and doing stuff. All right, we get to do some funny business now. We can watch a person's shell session. So again, when we're talking about Bastion hosts, we can actually watch what people are doing. So what we're going to do is I'm going to run this tool. So what this is doing is it's just going to print the entire process list, and then it's just going to highlight for me all of the references to the PTSs, or basically the virtual sessions. Like this thing is using a PTS, this thing's using a PTS device. So if I run this, what? Oh, it's the dumb quotes. Pardon me, copy paste. There you go. So you can see I got PTS 1 and I got PTS 0. So PTS 1 is this one here, and PTS 0 is this one here. So we're going to trace PTS 0. right?
Wow.
Right? So you can figure out if someone broke into the machine, you got a bash session, or you want to snoop on your employees. I'm not saying you do this. But you can figure out what people are typing. I mean, okay, so let's think about it less criminally. This is a really easy way for you to be able to do like screen sharing. You can SSH into a machine and run the snoop, and you can see what they're seeing, which is kind of cool, right? So I told you, we're getting into some funny business now. All right, so we're now out of the tracing. And that's how that works. So TTY snoop, I like that. That's pretty cool. Let's get a little more interesting. So bash readline allows you to figure out every single command that someone has ever, like anyone on the system is running in a bash terminal. So let's say you have a multi-user system and there's a bunch of people on it. You could run that and you can see what people running on the machine, right? So echo is a built-in in bash. That's not a process, that's a built-in. So it is intercepting that. Right? It can even figure out the pipes and print out the pipes. So we're getting full on, things that people are typing into the shell here. This could be really useful. I could rewrite this bash readline thing and have it send straight to logs and have it go to your scene for information security, right? So this is really interesting to me. Like you're able to intercept and see what people are typing and then use it for audits.
But with just that by itself, you don't know who owns that PID. So you need some reference
Yeah.
to that PID to find out who the owner is.
Totally. And eBPF allows you to it has a bunch of variables built in. So you can say, oh yeah, this is the user that owns the process. So there's some extensibility. But this is a great example of like just being able to figure out who's doing what. I mean, in this case, I can say, okay, PSOX grep 21254. Oh, it's a separate step. But yes, you could enhance this tool to give you those capabilities. So that cool stuff. All right, I saved the best for last. This is some real funny business. You are able to intercept SSL traffic and print it live over the wire. If you have root on the machine, it doesn't matter if you don't have SSL certificates, if you don't have the cert file, you don't know what's being used. This tool does is it intercepts the calls to SSL write and SSL read and prints what's being put in there. So you are able to see like sensitive data.
That is wild.
Yep. Now, granted, you already have root. You already rooted the box, but this is a way that then you're able to see what's going on. It's also good for debugging. Like if you run a HTTPS only service and you want to see what's going on that's happening over the wire, this is a way for you to be able to introspect that without having to do some nonsense with like OpenSSL. Yes? Yeah, just making sure. So let's run SSL sniff, right? Okay, so I got it going. Now if I, let's say, so this is my website. I'm curling it over HTTPS. Look, this is the payload in the clear for us to read, right? So imagine this was like, a REST call with an authentication token. You could get sensitive data this way. All right. So we're actually coming to the end. So in summary, those two tools, perf events, eBPF, I think you all agree now that you've seen it, it's a pretty awesome addition to your toolkit. You probably won't need all of the tools that it provides, but there's a handful in there that I'm sure you found really interesting. And it gives you a level of detail and granularity in the behavior of processes on a Linux system greater than you've ever had. And you can use them now. And definitely with great power comes great responsibility, test and non-prod. Yeah, otherwise have fun. Further reading, So Brendan Gregg, how many of you know about him? All right, that's a dude you need to check out. So this guy works for Netflix now. He is probably the biggest, most prominent engineer when it comes to performance engineering. He wrote a gigantic tome about BPF and performance tools. A lot of those tools he wrote. So if you really want to go deep, you can buy the book. And then there's also some references to the perf events, the GitHub project, and Julia Evans, who's a prominent sysadmin, created a great perf cheat sheet that you can download that shows all the perf stuff. And again, definitely check out the syscalls. I know it seems like dry reading, but this is actually how I got into Facebook. I memorized all those things and used them in interviews. So, keep that in mind. So that is all from me for this talk, and I'm open for questions and feedback.
Are you going to share the slides by chance?
100%.
Okay, yeah, send me a link and I'll post it on the meetup.
10-4. Absolutely.
What's this QR code for?
Oh, that's my website.
Okay.
So yes, I am a consultant. I'm always looking for clients. That website has a blog section that I post to pretty often with a lot of free material, including recorded talks about site reliability engineering, defining service level objectives, lots of SRE content. I also sell a couple of services, particularly an assessment of your operational responsibility maturity for services that you might be running and responsible for, as well as a one-day reliability boot camp. Just in case your team doesn't know how to run production, I can get you from 0 to 100 in a day's time. But yeah, that's all from me. I'm open for questions.
Come on, you guys have to have questions.
We asked during the talk.
You did. We also can go back and go over the basics if any of you find that interesting, and if we're good on time.
Yeah, I mean, we've got like probably 15 minutes if we want to detour to some of the other stuff.
Okay. So is there anyone in this room that wants to go back to the beginning and talk about the basic Linux host debugging tools and methodologies? Would that be useful to anyone in this room? All right, we got at least one. We got two. All right. So go ahead.
I have a question.
Please.
So one of the things is that I'm looking for is baseline understanding. So once the system's up and running, right, and you say that it's secure, and you see the average connections, how or do you have any recommendations of establishing a baseline of the system, right, and then being able to check against that baseline over a period of time to see if anything, whether it's HTTP requests out to a host or call into new files on the file system. Do you have any type of solution?
100%. Yeah, totally. So if we're just talking about homegrown, like things you want to build yourself, now we're talking about getting into the world of observability, right? And the easiest way to get started with that is to learn Prometheus. So Prometheus is a open source free time series system that allows you to scrape metrics from services, as well as like just full on, host metrics. So you could do that, run a Prometheus instance, scrape your services as well as the Linux machines themselves, and then that comes with a big panoply of data that will allow you to establish that baseline and the key metrics that you care about, and then you can see them change over time, and that will allow you to help explain what is happening on your system. Though what I will say, just as an aside, since I am a site reliability engineer, I would recommend when talking about your system, think about the top level metrics that are most important to your users, measure those, make sure you have those service level objectives. And once those start to change for better or for worse, then you can drill into those metrics I just mentioned to explain why that is the case. But yes, you can generate a baseline pretty quickly with Prometheus setup, and I'll be glad to talk to you more about that, in person after this talk, because I actually have a workshop that will spin up a Prometheus instance for you, and you can play around.
Remember back, I used to mess around with the Elk stack. Is that kind of like gone now? Like Prometheus kind of took the foothold there?
No, it's still there. So elk is like, that's mostly for logs,
Okay.
whereas Prometheus is for time series, so gauges and counters. So there are some teams that use Prometheus and elk together, or they will use something like Graylog or Loki, but those are all for logs and log analysis. And there's a bunch of SaaS companies out there that will more than happy to accept your logs and help you analyze them. Honeycomb is a pretty interesting one. We can talk more about that if you like.
I remember. Yeah, the person I used to follow her on Twitter. Yeah.
Charity Majors.
Yeah.
Yeah. No, I went to Observability Day in Boston back in May, and they did a whole crash course on OpenTelemetry and their service, and it's wild. But yeah. So no, elk is still around. The problem is that the operational responsibility involved in running one and running one well is pretty significant. So that's why some people run Loki instead, and that's why some people just pay a vendor to take logs for you.
Is Prometheus like on a large maintenance overhead as well, or is it pretty?
Some. One of the biggest problems you can have with Prometheus is you just scrape all the metrics and you're not thinking a whole lot about what is valuable to you. And then you end up having a gigantic data store and then you have to scale it. So one of the big pain points with Prometheus is to manage and reduce the cardinality, which is a fancy word of saying, what are the different variants of metrics that I have? Because the more diverse your metrics are, the bigger the storage is in order for you to query it. So that would be the one operational burden of running Prometheus. But you would have to deal with that anyway, regardless of what vendor or tool you use in order to minimize costs. That's
How do
really
you see something like Nagios fitting into what you're talking about today?
interesting. Because
Because this is all real time. Nagios is monitoring something slightly different, but when you're monitoring your processes, what's going down, it's for making sure your web server stays up, making sure your PHP stays up, restarting the processes if they die.
yeah, that's really interesting. So I used to be a pretty big local expert in Nagios and ran a gigantic cluster and did mod Gearman and all that crap. So you asked the right guy. So when I think about Nagios and monitoring, that is telling you the what. These techniques will tell you the why, right? So ideally, your monitoring checks, regardless if it's Nagios or Prometheus Alert Manager or Grafana's monitoring, you're looking for certain conditions on your system that are not desirable, right? And for example, a disk getting full. Well, all right, great. A disk is full. You're running out of space, but that doesn't tell you the why. And those tools, you could run your StatSnoop or the file top tool, and you can be like, oh wow, this thing is generating a bunch of temporary files or something. So again, that's why monitoring would be what. Amazing question. All right. Any other questions before we jump briefly into the basics? Rock on, let's do basics, and you can cut me off at any time. This might be interesting to some of you. For some of you, it might be a review. At least you'll like the format of the slide deck. So I did this talk a while back for DrupalCon when I used to be part of that community. It's basically all of the heuristics and the ways to think about troubleshooting systems using the basic tools now. So we're going to take a step back. Who am I? You know me. You know what I do. So we're going to talk about a few things. The use method, which came from that guy, Brendan Gregg, I was telling you about. He invented this process, and it's really simple. We're going to be talking about hardware resources and software resources. We're not going to talk about process introspection because we already did that. And outage scenarios I ripped out of the slides 30 minutes, like an hour ago. So we're just going to talk about these things. So imagine everything's good in the world. You're sleeping. It's 3 a.m. You're taking a nap. You get a phone call. It's an alert. You got paged. There's an incident. So what do you do? All right. Usually in these moments, you panic. You're feeling the heart palpitations. You're like, oh crap, the site's down. I need to respond quickly. So what we're going to talk about is the basic tools you need to be able to understand what's happening on the system, simple tools and processes to gather information, and then learn how to actually interpret the data to zero in on what's going on. So BPF, perf events, that's like deep down. You're not necessarily going to be using that to figure out causes of outages unless that outage has been going on for a while, and these tools did not help you. So start here. I was in the trenches in an operations team for 5 years. Catch me over a beer sometime. I will tell you some pretty wild stories. I have taken all of that information and I've condensed it into this talk. Let's begin. So here's the misconception about people like us that understand the infrastructure. You must think of us as freaking wizards, right? Or you think of us as some kind of crazy cyborg that just like, jacks into the matrix and we're able to interpret all of this data without even freaking thinking about it. But the fact is, actually, we're humans. We just have tools and processes that we know about, and there's patterns in our head about things to check based on what we've learned from previous incidents, heuristics. So you can learn what we know, and I'm here to share some of those insights with you. Before we begin, same setup, right? We're not doing any demo in this talk, but it's LAMP stack, CLI, SSH, right? To begin, let's give you a little easy framework. It's called the use method. So Brendan Gregg, again, performance engineer at Netflix, very smart guy. He developed this method to make troubleshooting straightforward, complete, and fast. But okay, fine. What is it? That's it. For every resource, check utilization, saturation, and errors. And when we mean every resource, I mean every, because it's going to give you the full breadth of everything that's going on in your production system. And there is going to be a point where you're going to find saturation and errors. But what do those things even mean? So let's talk a little bit about what resources are first. And when we're talking about resources, it can be these things, physical server stuff. So CPU, memory, disk, network, basics, right? We could be talking about software components. So these are like the configuration settings that you can have on a system. So for those familiar with LAMP, we were talking about PHP proc pool and tuning that properly. That is a resource. The cache in MySQL, that's a resource, as well as the functional components of the operating system. How many files you can have open, how many processes you can have launched, and so on and so forth. So what is utilization? That's basically the time that a resource was busy doing work. So you can have a percentage over interval, and you can define how much a resource is in use over a given period of time. I think that's pretty straightforward, right? Saturation is the moment when you have used all of the resource, so you've utilized it to the point of saturation, and now requests that are hitting it are beginning to queue or get dropped, right? So you got your shopping line, right? So think about you're at Walmart or a grocery store. You have 4 cashiers. If those 4 cashiers are all serving customers, that is a saturated resource, and you can see that now there is a line. So that is saturated. If you had 3 cashiers, no line, it's 75% idle because 1 person is free. Errors. I think this is pretty straightforward. This is when a resource is in response to a request comes back with a message saying, hey, I can't do the thing you wanted me to do. For example, input-output error if you try to read a file from disk for some reason and it didn't work. And you can get this information from logs and error messages from your app and things like that. And yeah, Zelda too. So let's get into actually how to do this. So we've done the preamble. Let's get into the tools. Again, CPU, memory, storage. It's not just how much storage is available, but also the read and write rate, because there's an upper bound on how much you can read and write to a block device, and the same can be said for network. So we're going to be looking at all of those things. How many of you use Top or a variant on it? Good. It's a good tool. But I am going to tell you something. I've interviewed a lot of candidates as a system administrator manager over the years, and then I tell them, hey, can you tell me what's going on about CPU? And they say, oh yeah, no problem, I run top. And then I'm like, interpret this line, and they can't. So what I'm just going to warn is that if you are new to this whole thing, don't use those all-in-one tools. Use some of the tools I'm mentioning to you, because then you'll more easily gather an understanding of what's actually happening, rather than trying to decipher this all-in-one, very convenient but very confusing tool. All right, so CPU. So we were talking about top, right? In top, one of the top bars is going to have these things. Does this look familiar to any of you? Rock on. So we're going to talk about what these things are. And these are the common ones, and this is important. So if I ever start interviewing candidates for my consultancy, I'm going to be asking you this question, so there will be a test. So USR is time spent in applications, running processes in user space. So if you see high user metrics, that means that the CPU is doing what it's supposed to do. It's running apps, but you could also have too many processes running, overloading the CPU. System, so that's time spent in the kernel. Typically, when I see high utilizations of this, it's time spent talking to a network device for web services, typically. I/O wait, this is something people tend to forget, but this is actually pretty huge, especially when we're talking about like databases. So this is the time spent by the CPU waiting on responses from block device. So if you have a disk that's slow, you will have high levels of I/O wait if you have a high rate of requests, let's say a bunch of requests to a database server. And then idle, this is straightforward. This is the time on a CPU that nothing's happening. And when we're talking about saturation, if this is 0%, we're completely saturating the CPU. There are tools like, so top, if you press 1, it will expand the view on this per core, but usually you'll see this all in aggregate, the sum of all of the cores. And there's some tools that are really cool for this. I'm not gonna do demo. There's DStat. DStat, I think, might have changed its name over the years because Red Hat took that tool's name over from DAG Weirs, which is a total absolute crime. But I think most systems, if you install DStat, this is what it is. And it gives you a per second breakdown of the CPU utilization as well as many other metrics. I highly recommend this. MPStat is similar. Now, if you want those top tools I was mentioning, we mentioned HTOP a little while ago. Top, the classic, is everywhere. And then ATOP, I was mentioning earlier about process accounting if you want to do the old school, hey, what happened on a particular time if you don't want to set up Prometheus or something and it's just one box. So let's do a little pop quiz. Let's take a look at these 4 things and speculate about what each is happening for each set of metrics. Audience participation encouraged. So we got this thing over here. Check out the idle and check out the wait time. What do you think could be happening on here? Okay, that's a reasonable guess. What about this one? So we got low user. We got some system and mostly idle. What could be happening here? Shell session? Maybe. What do you say?
Network traffic.
Network traffic? Sure. What about this guy here? This is pretty easy, right? Just hanging out and doing nothing. You should probably turn this off.
That's my application I wrote for myself.
That's right. And then what about this one?
That is what I wish the application I wrote.
You win. Yes, this is like an app server. So let's see if we win. Survey says, writing large file, system is idle, network file transfer, CPU stress test. Good job. That's absolutely right. So yeah, we were doing read-write operations. We were doing some SCP nonsense, and then yeah, I was running. You say, okay, you guys are liars. You guys are liars. So to dispel what uptime means, so it's giving you something called a load average, and it's displaying the number of processes that are in the run queue to be processed by to be scheduled to be executed over a 1 minute, 5 minute, and 15 minute window. Now here again, if I ever interview you in the future, know this one. If the load average is greater than the number of cores on your machine, that's a saturation metric. Okay, so ideally, there should be a one-to-one correspondence. Like if you're running an app server, the load should not exceed that of the number of cores. And you can run nproc all, and it will tell you the number of cores you got. So in this example, if I run it, I got 4 cores, and my load is 1.62. So we're good to go, at least on the load average side.
Except you have 2 cores sitting there doing nothing.
Correct, 100%. But at least you know it's not a saturated resource.
What about like EC2s and stuff? Isn't there weirdness with the whole like virtual CPU situation? Like, does this actually work?
It does. So one of the things that actually happens, you don't see it here, but there's actually an extra thing in the output that DStat doesn't display, but Top does, which is steal. So if you see steal metrics increased, that means that the hypervisor is taking cycles away from you. Usually that happens for EC2 instance types that are like high memory, low CPU. What they're doing is they're just holding back the CPU they would otherwise allocate. Like an M1 medium, if you were doing cloud stuff back in the day, M1 medium would be a really good example of something where you would have that metric. But no, those metrics still work in virtualized environments. Good question.
And I believe AWS, all their cores are half real, half virtual. When you get 8, you're really only getting 4 real and 4 hyper-threaded.
But you can actually also change it. It's optional, right? You can pick like a real machine, right?
You can, but they're really expensive. But like so what happened in the ancient days, Amazon decided on something called a elastic compute unit, and they've been using that as a measure of work throughout the entire time that they've been running cloud. So an ECU is an ECU is an ECU in theory, right? That's how they get around that. So now we talked about CPU. How are we on time?
Like 5-10 minutes.
I think we got enough to plow through this stuff. That's awesome. So next is memory, right? We got memory used to run applications. That's what it's for. You can run free-m, and it will give you this output. And we have, so used, this is the amount of memory that's actually being used by running apps. Shared is what is being passed around between processes. This here, this is what we were buffers and cache. So they usually sum it together. This is the stuff used to read and write to devices. But this is what we were talking about earlier, cached memory. When you're accessing files, the Linux kernel automatically stores the contents of those files in RAM. So when you need to access it again, it is fast rather than reading from disk every time. And then available is the actual amount of memory that can be used by the system to allocate for more processes or existing processes that are asking for more memory to do its operations. And if you're running an old system, like 10 years old, you might not have available. Look here. This is the value you want. There's a great website called linux8myram.com, which explains all of this. Because what happens is that, newbie sysadmins are like, oh my goodness, look how low this is. This is a problem. No, it's not. It's the disk. It's the disk cache. Disk caching is happening, and that's perfectly fine. So what happens when you run out of memory? We talked about this. Swapping. So swap. How many of you don't know what swap is? No shame. Oh, rock on. Okay. So you got a region on a disk. It could be a partition or a swap file in the case of Windows that basically holds on to pages of memory. And what happens is if you have more processes than your physical memory, it will swap out pages into the disk in order to make more room for running processes. But of course, a disk, even like NVMe, is going to be an order of magnitude slower than RAM. So swapping, while it does give you a larger pool of memory to use, slows down execution of your process. And you can check that with free-m again, and you can see, the swap. So if you, back to our previous conversation, if you're seeing a lot going on here, you might want to consider, that might be a signal that you need to capacity plan your RAM better. So I mentioned this briefly, but let's talk about it more. What happens when all of the memory is exhausted on a system? Let's say you even have swap, it uses up all the swap. the Linux kernel has a feature called the killer. The killer watches for this condition and starts killing off processes to free up memory on the system. And you can look at the kernel log or run the tools message and you can see something like this. This is bad. This is real bad. If the kernel killed MySQLD, that is really bad. Can anyone tell me why?
I like database.
What's up?
And no more database.
I mean, yes, no more database, but it's even worse than that.
No, but anything that hasn't been written to the disk yet that's still in cache just went away.
Thus
So-
spake the sysadmin.
You no longer have an ACID database.
Right, because you didn't flush your dirty pages to disk, and therefore you now have data loss. So you can actually configure the killer to prefer certain applications over others, so you can protect MySQLD from being killed when the killer is invoked. But this is something really important to note. Just as an aside, there's even user space level killers. One is called D that was written by Meta back in the day if you want to do a user space killer for some crazy reason. So we talked about memory. Let's talk about disk. I'm sure y'all have used DF at some point in your career, if not dozens, hundreds, thousands of times. So you can run DF -M -X, and you can exclude some file systems you don't care about. So DF-M will give it to you in megabyte blocks. You can also use DF-H for human readable. And you can see here, used in megs, available in megs, and then it does the math for you and figures out the utilization. And then, of course, if use is 100%, it's full. Really straightforward. Actually, it's not that straightforward. How many of you know about inodes? All right, we got some of the hardcore sysadmins here. So when you create a file system, part of that is allocating the storage of the disk to store file system metadata, particularly inode data. What an inode is, it is a piece of information that is storing metadata about a particular file. How big is it? Who owns it? What the read, write, execute permissions are on it. When was the last time it was modified? When was it created? So that is all stored in an inode. And when you create a file system, there is a finite number that is provisioned at partition time or at format time. So if you end up writing too many files, let's say you create like a bunch of little temporary files, you can eat up all of your inodes. So what can happen is you can try to create a file on your system and it can say, nah, man, no space left on device. You run DF like saying WTF, and look, everything's good. No. If you run DF -I, you see, oh, snap. My root file system is full. All my inodes are gone. Now you know actually what's going on. So that's also an interview question, so keep that.
I would definitely run into that.
Yeah.
I have to remember I was freaking out about that just 10 years ago.
My advice, XFS, that'll solve your problem.
XFS is a pretty lovely file system for cloud workloads. I recommend XFS as well for a lot of reasons. I'm right there with you. So DF -I, it's on the test. So we talked about capacity on disks, but what about disk I/O? This is really good information. This is the only command you'll ever need if you just want to figure out what the heck's going on disks. iostat-mxt1. iostat is a tool that's provided by the systat package, and it gives you the full thing, all of the statistics and megs across all of the block device you have on the system. It even tells you the CPU utilization. Remember these? It even gives you those, and then a timestamp. So you can run that. It'll keep printing this output over time, and you can see what's going on the system as maybe you're loading in a database file or something. So there's a bunch of metrics here, but there's a few that I want to show you. Read and write megabyte per second. I think that's pretty straightforward. How many megabytes are being written and read to the disk? And then you got this await. So this is the average time to process requests. So if you see await values that are really high, so this is like the average across, like in general, and then this is read and write. So if you see really high metrics, there could be something wrong with your disk, especially if you're like in the cloud you can have a problem with the network block device. Like I've seen EBS outages where you have util at 100%, read and write really low, and then the A-weight values are through the roof. So IOStat gives you a really good snapshot on a per second basis as to what's hitting, like what disks are getting hit. But as we were talking about in the previous talk, that talk talked about the why. This talks about the what. Okay. Now, similarly, we can talk about network I/O because network is a finite resource too. Most systems that you're running are just gigabit, and you can check with ethtool, and you can figure out what the speed of the card that's installed, and then you know the theoretical maximum. And then you can then measure what your data rate is. So you can run bandwidth monitor-ng, and it will give you, per device, your read and write rate. When I wrote this talk, I did not know about SAR. SAR has a capability where it actually prints metrics on your network card that looks just like this, which is really cool. So if I had a few extra minutes before this talk began, I would have probably put SAR output on here. But BWMMG is pretty nice too.
Do you use ZipTop?
Sometimes. I usually use that, or I use IPTraf, which is like ncurses, and that's pretty nice because that also gives you like statistical breakdowns of like hosts and things, kind of like what the BPF tools do. All right. But yeah, you can get your network I/O. Should we pause here? Because now we're talking about software resources, and that's esoteric. Cool. Awesome.
Thank you very much.
My pleasure. I'll be glad to share that. All right. I will give these to you.
Thank you.
Mm-hmm.
I'll put my laptop up over there if you want to grab your laptop, just because I'm going to steal the screen.
Thank you very much.
Okay, let me end live. Bye-bye.